Ladies and gentlemen, I would like to make a statement. I made a mistake in the last video. I did. So I posted it on Classroom for those of you that have not seen. There's a correction to all the problems in the video. The number should have been 6.25 times 10 to the 18th, not times 10 to the 25th. So my apologies for that. I will not make the Castle Learning that was due mandatory or grade it because of that. I did reset it for everybody if you'd like to go back and double check your answers. So let's look at the Castle Learning for a quick moment here. And look at some of the questions. So first, let's look at number 6. Number 6 says we have a metal sphere having an excess of 5 elementary charges. What is its charge? So first, what you want to do is start with plus 5e, and then we will convert it to coulombs like we need to for the problem. So we'll do that just like we practiced yesterday. Put e down here, coulombs up here. So I know 1 coulomb is 6.25 times 10 to the 18th e. So let's grab a calculator here and go for it. So I've got 5 divided by 6.25 times 10 to the 18th, and we've got 8 times 10 to the negative 19th. So we have 8 times 10 to the negative 19th coulombs, which matches up with choice 2. So we've got our answer there. Now, some of you might have been confused because of the hint being given here. They are using this number, 1.6 times 10 to the minus 19th coulombs, to get to the same answer. So you might have been like, DeBello, what the heck is this 1.6 times 10 to the minus 19th? It's actually just the inverse of 6.25 times 10 to the 18th, if that makes any sense. So like if I did 1 over 6.25 times 10 to the 18th elementary charges, I would get 1.6 times 10 to the minus 19th coulomb. So they're just inverses of one another. I like to use 6.25 times 10 to the 18th because I think it makes sense that there's that many electrons in 1 coulomb as opposed to less than 1 coulomb in 1 electron, which is kind of a little bit backwards. So you can really do it either way, but I like using 6.25 times 10 to the 18th to do all of these problems. So let's move on quickly to what we are going to do today, which is just going to be a brief kind of explanation and extension of what we learned yesterday. All right, to the whiteboard, and what we have here is a wonderfully beautiful picture of someone touching the Van de Graaff generator. So a few things I want to point out is both objects here are on insulating stands. Why might that be important? Exactly. That's going to mean the total amount of electrons that are on both of these objects are going to stay on both of those objects and not travel to the ground. So let's say in a hypothetical situation that this Van de Graaff generator generated -4 coulombs of charge. So there are -4 coulombs of charge on that Van de Graaff generator, and then it was turned off, so it's not creating any extra electrons. So what are those electrons going to do? As we talked about many times before, electrons will always spread out as evenly as possible over the objects that they can. So in this case, since this person is touching this sphere, the electrons will travel from this sphere into this person. Now, how are they going to spread out? Is the charge going to spread out? Could we say that, hey, we have maybe -2 coulombs here and -2 coulombs here? And would that be cool? It could be. That could be possible. But in this case, it's not likely. Why do you think that is? Great. And that's because this object, the person, is much, much larger. So they have a greater capacity for those electrons. So more than likely, what would happen is we'd end up with something more like this. Maybe -1 coulomb still on the Van de Graaff generator and -3 coulombs on the person. So what you might be thinking is, hey, is there a way to calculate this? There is, but we're actually not going to get into it in this class. What we are going to get into is what happens now if I have two identical objects touched together. So what we're going to talk about is like, all right, if I have two identical objects, both on insulating stands, so I'm just going to draw some square blocks, which are clearly insulating stands. You could tell my art is beautiful on this computer. And let's say on these stands, we have two just metal spheres that are identical in size. And that's important because that's going to let us know that, hey, if I have, let's say, 3 coulombs of charge on this sphere, which might mean it's missing electrons, right? And -1 coulombs of charge on this sphere, meaning it has extra electrons, I know that the charge will evenly go. Just like in this example, if this person and this Van de Graaff generator were equally sized, the charge would split equally. So I know when these two objects touch, the charge is going to be split equally on both of them. So, can you guys figure out how much charge is on each one? Hey, let's give it a shot here. So, to figure this out, all we have to do is figure out what the total charge is. So, hey, what's the total charge of both of these? So the total charge we have would be 3 minus 1, which is +2 elementary charges. So that means that total charge, if these two are touched together, so if they're touched together, right, in the next scenario, these two spheres would then evenly split the total amount of charge. So we know the total amount of charge is 2 elementary charges. That charge is going to split evenly between them, so each one should have a charge of +1e. So this is all really kind of easy to figure out as long as we understand that the two objects are identically sized and they're on insulating stands. Two very important parts to being able to solve these problems. So what you guys are going to do this weekend, so due at 8 a.m. on Monday, is going to be a very short worksheet. Oh, Mr. Bell, how are we going to turn it into a worksheet? We're doing it from home. Oh, good point. What you're going to do is you are going to take a picture of that worksheet and upload it to the Google Classroom post and hit submit. So you're going to upload it like you would a lab and hit submit there. Again, if you have any questions, today at 10:15 a.m. we have our first office hour. So I will be sitting, most likely staring at a picture of myself on a computer screen until somebody hops in. So please hop in, say hi, ask some questions about what we are doing. All right, guys, have an excellent weekend, and I will see you guys Monday. Is it turned off?